So here I am recording again. Let's see here. How do I want to do this? Let's see if I can just go back to where we were. Yeah, much better. So let me share my screen again and let me talk about lists briefly. So here's how you use lists. Lists have constructors. They're very similar to vectors in a sense. You just say, I want a list of ints, something like that. Not too bad. This is essentially what you'll be doing in your trylist.cpp. Instead of including vectors, you'll include list, because that's where the list class lives. And then if I want a list of, for example, doubles, I can say, I would like a list of doubles, please. Just like you can make a vector of them. I'll call it L, all right? And then let's pretend that I want to put things in this list, right? Let's add like 3.14, let's add pi to it. So L dot like push back, just like a vector. 3.14, we can add another thing like 5.67. That's how you can use it. There's also push front, which you'll be using. Lists have a few things that are different from vectors, more things in fact. So you can get the first element and the last element very quickly with front and back. Maybe I'll try an example of front. So dot front will give me 3.14 because that's the original thing, because these get added in order, right? So the list right now, 3.14, 5.67. And I'll use these square brackets to differentiate it from like a vector or an array. That's a list kind of style. And so cout L dot front gets the first element, which is the 3.14, the one at the front of the list. Yeah, that's most of the battle. And then you can iterate through the entire list with what's called an iterator, which is a different type. So that's where the begin and end come from. Okay, so here's an example of it. It looks a bit weird, but I'll explain it to you and hopefully it'll make some sense. Okay, so here's how you can iterate through using iterators. So an iterator is kind of like an abstraction over a pointer. It's like it has the pointer-like operators overloaded in a weird way. Here's the standard way of doing it. You can say for, I want to go through a list of doubles. And I want to use what's called an iterator to go through them. So it's a type defined inside of the list double class. I want a list double iterator, please. Usually we call it IT. And I want to start it at the beginning of the list. That's what the pattern is, if you see it like this. And then usually you're all about like IT is less than something, but usually when you're using iterators, you say, I don't want to go past the end. So you say, I want to stop when IT is equal to the end of the list, L.end. This L.end doesn't give you the last element. It gives you like one past the last element. So you're not going to like forget about the last element when you do it this way. And so this will be true as long as you're not one past the end. So you want to continue the loop. And then you can say IT++. And this will advance the iterator throughout the list. And then we can use it, okay? IT is like a pointer to the current element of the list. And so if we wanted to print that element, I can just say cout star IT and it gets that element, okay? I'll print them out with spaces. And so now each element will get a chance being IT because we're going to iterate using it with IT++. And that'll be that. Yay, so I get 3.14 space, 5.67, because they all have a chance being pointed to by IT. It's like iterators are like pointers, and this is their type. It's very weird, but that's how it works. So this is essentially what you'll be doing in your trylist.cpp, and all of the other containers similarly have iterators that you can go and look up on their pages, okay? See how those examples look. And again, since we're using namespace standard, we don't need any of that, okay? So I think that is all I wanted to say about lists. Does anybody have any questions? I'm going to give you this code, and I also started recording again. So you should have this in a bunch of different ways. All right.